Yali everyone, Italy here. I'm going to go ahead and continue on to the next lesson with regarding the calendar. So the last where I left off was the Alfonso Caso correlation, which I concluded that it wasn't really a complete correlation. Today we're going to talk about the Rafael Tena correlation, and we're going to we're going to compare it and kind of see where it's at and look at how accurate it is compared to what the calendar is supposed to be based on what we've learned so far. And so for Rafael Tena, today is it's February 26th. This is supposed to be the first day of the Rafael Tena correlation. And so here it is on Instagram. You can follow this page here to, they periodically put the calendar. They follow the Tena, and a lot of the academics in Mexico follow the Tena correlation as well. And so it's very popular over there. And so I'm just gonna go over it and show you how accurate it is compared to the Caso correlation. So the Alfonso Caso correlation, as we saw, was extremely inaccurate because it did not incorporate a leap year. Well, the Rafael Tena is starting on 7 Osomatli. And so we're going to look at it and see what kind of how it compares to the Caso. And there is this short little article from Rafael Tena himself. He's a researcher over there in Mexico. And so let me go ahead and highlight some of the important points that he brings up here. So if we look at this article, we see that he is talking about the leap year, okay? And so among the Mexica, the year would have had a fixed length of 365 days. And so he says that he's talking about Caso here, Alfonso Caso, and he said that Caso denied the existence of the periodic adjustment among the Nahua Mexicas. And he based that on Motolinia, who's a Spaniard. And here's a quote from him. At the time that this land was won, the beginning of March, they began their year at the beginning of March, but for not reaching a leap year, it would go away, varying its year for all the months. So the Spaniard knew that if they don't put a leap year, it's going to trail off, which is what I showed you in the last video. Yet he said that's what it was, right? That's what happened. And so Caso, apparently, according to Tena, was following that particular Spaniard. I want to remind you that all of the Spaniards disagreed. They all had a different view of it. And in this case, we have Tena. He is pointing us towards another Spaniard, right? And so he's saying that there are other researchers who agree with Sahagun, not Motolinia. And Sahagun is saying, well, they held a festival every 4 years in honor of the fire, and they made their leap, counting 6 days of Nemontemi. Nemontemi is the last month of the Shupoali. And so he's saying that they added 6 days instead of 5 days, which is what I was showing you in my planner the last time, where I have that 6th day, the Nemontemi. And so that the 6 days, because the Nemontemi is usually 5 days, right? It's a 5-day month because it's like it's like 18 months of 20 days. 18 times 20 is 360. So you have to have that Nemontemi for 5 days to make a 365 days. Well, here, of course, Sahuagin is claiming, well, in that 4th year, you have to add a leap day, which we know is the case. And so he's saying that his statement is corroborated by their testimonies from the chronicles. Okay. He's talking about this source and also this source. And so, Tena is saying that we have to apply a leap day. And that's what this calendar is doing. This calendar is incorporating a leap year every 4 years, which we know is necessary. It's a necessary adjustment for all solar calendars to keep them, aligned with the sun. And so if we're looking at Caso and Tena, well, Tena is making a really good choice here because we know that it's necessary. In fact, he points out the same thing I pointed out in the Caso calendar video, that the fall of Tenochtitlan was on 1 Coatl, okay? And he's saying, as I pointed out, that it is necessary to take into account a 6 Nemotemi day, okay, in order to get to this date from the first date, which is 8 Ehecat. Let's see if I can find it here. So if you don't know what I'm referring to, you know, you got to check out the other video that I made. But basically, what happens is there's a day, 8 Ehecat. This is when the Spaniards entered Tenochtitlan, and so I can't find it now, but let me see if I search for it. Hold on. No. Okay, well, he's saying that for that day, 8 Ehecat, to get from there to 1 Coatl 2 years later, from 1519 to 1521, in the two most reliable Gaso dates, you need to have a leap year in between. Otherwise, you cannot go from one to the other. That's a critical fault of Gaso. Gaso did not address that. You know, he put together all the sources, and yeah, he said, okay, these are the most important sources to calibrate the calendar, but he did not address that you cannot get from that 1519 point to 1521 point without adding a leap day. And so critical fault of Caso that Tena is obviously addressing here. Now, one of the sources that Tena uses is the Codex Magliabechiano, folio 92R, which we can see here. Now, he uses this as a source to show, hey, this is evidence that there is 1, 2, 3, 4, 5 days. And then this day is a little bit larger, making it, he argues that it represents the 6th Nemotemi. Now, this particular page, it's most likely these are offerings to the Theo that we see on the page. And it, you know, if you look at this codex, it's kind of it's not talking about the calendar. And so he's probably most likely wrong in his interpretation here, because these are just offerings to the Teteo. But what the interesting thing about this image is that it is a pretty accurate depiction of what is happening. So 1, 2, 3, 4, 5, and then on the leap years, you know, you have an extra day, which makes it, you can kind of think about it as like a day that is stretched out into 2, so it's like a larger day, which is why the 2 day signs would repeat, as I showed you on my planner in the last video. So probably not referring to the Nemotemi. I have a better symbol that is definitely showing the Nemotemi, which he also cites. It's from the Lariano Romensis, and so this is a very cool symbol that does in fact talk about the Nemotemi, because if you look at this page, it's the last month of a series of the Xiopwali months, and it's showing us that, okay, we have 5 days, but the really cool thing is that the 5th day is singled out. You see the coloration is reversed. You see that? All these days have the same coloration. This one has the red on the outside and the white on the inside. And so this is very clearly telling us, by the way, the Spaniard, there's Spaniard writing on this page if you look at it, but it was so funny because he does not even understand what this symbol means. Like a lot of times, like it just shows like Spaniards don't understand the calendar, you know. And he was like crossing it out, like, oh, he was trying to say, what does this mean, 4 days? And he was crossing it out 6. He couldn't figure it out. So it's really funny to look at. But there's a 6th day here, and this is the leap day every 4 years. Okay, leap day. And look at this. the native writer who drew this, obviously understood what was happening, unlike the Spaniard. And so this is the same as this. So the 5th day is the same as the 6th day, right? And so that's telling us that, like I showed you in my planner, the 5th day of the month has to be the same as the 6th day, because it's considered to be just like one long day. And so this is really good evidence. It's definitely showing us the existence of the leap day. And so, all these people who say, oh, well, you got to have sources to support what you're saying, these secondary sources. Well, this is all showing us that, what's the point of looking at the secondary sources? They all disagree with each other. You get one Spaniard saying there's no leap year, another Spaniard saying there's leap years. You can have, several Spaniards saying one thing and several saying the other. It's just not really going to be counted as evidence, which is why Ruben Ochoa says we have to look at the mathematical patterns and the pre-Columbian codices, because how are you supposed to make any meaning out of all of this? You know what I mean? And so it's a really interesting point that Ochoa makes that a lot of people don't understand, because a lot of people are saying, well, where are your secondary sources? Well, don't cite the secondary sources because they're all contradictory. And this is a key point here. Okay, so at this point, just to summarize, we know that a leap year is required every 4 years, and a leap day, which is an extra day, a duplicate of the 5th Nemontemi, the last day of the year, the 365th day, we're duplicating that. And Tena did that. So that's great. He did it. And he's citing Spaniards, which is not, again, the best practice, but I mean, at least he did it. So his calendar off the bat is going to be way better than the Caso calendar. We know that it's going to be much more accurate. So let's go ahead and look at, my calendar page and see where it's at compared to his. So today, according to him, again, this is the first day of his calendar, and it's Chicome Osomatli, which is 7 monkey. So let's go ahead and take a look at the Ochoa correlation, the real correlation that we know is 100% accurate. And we're gonna go and look. Same date today is 1 tekpat, or say tekpat, 1 flint knife, 1 flint knife, and again, this is 7 monkey. So you might be wondering, well, he put in a leap day and a leap year. Why are they different, right? You might be wondering that. You should be asking that right now. And so let's go ahead and find out where we're at here. So we're going to go to Tekpat. So this is where we're at in the Ochoa correlation. And his was 7 monkey. So we're going to find a monkey. Monkey, where are we at? Osomatli. Look at this. Now, one thing I want you to notice is the Caso, the day was like way, like hundreds of days away, right? It was like a huge amount of error, right? Now, with the Tena, what do we see? We see it's behind, right? It's like, wait, it's behind by 1, 2, 3, 4, 5, 6, 7 days. So it's 7 days error. 7 days of error. So it's trailed back 7 days. And so, again, way better than Caso. It's not hundreds of days, it's 7 days. So accuracy-wise, it's not too bad. It's very close to where it's supposed to be. But the question is, why is it not on 1 tekpat? And that's what I'm going to answer now. So again, if you don't understand the mathematical patterns, then there's no way that you're going to understand these calendar counts. So we're gonna have to go back to the math now. And so let's go back here. Now, if you remember from the previous video, I told you all that the caso count does not incorporate a leap year. Well, the Tena does, and I told you the actual length of the year, the solar year, which is here, and so we have it's 365.24. Well, if you remember, by adding a leap day every 4 years, you're making an extra 0.25 days every year, okay? Or 1/4. Well, here's the problem. This 24 is not the same as 0.25. So we're putting 0.25 extra days, but it's actually 0.24. So let me go into my calculator so that we can see why that's a problem. So we have 0.25 minus 0.24. And so we come up with, by adding the leap day every 4 years in the leap year, what we're doing is we're adding an extra 0.01 days, okay? So we're actually adding 0.01 more days than we should be every 4 years. And so that is a tiny number. It's a minuscule number, 0.01. It's like that shouldn't really affect anything, right? And it doesn't for a very long time. But watch what happens when you multiply 0.01 by 100. So what we're saying here is there's 0.01 extra days every year. And then there's in 100 years, you will accumulate 1 extra day of error. And this is error because we're adding this, right? To make it in line, but it's an extra day of error now. And so what this does is, this is the cause of the Tena correlation moving back 7 days. Okay, and so basically what's happening here is the Rafael Tena correlation is the same as the Julian calendar that started to accumulate error. Now, of course, when the Romans were using the Julian calendar, they didn't notice an error. Why? Because it takes 100 years for the error to accumulate, right? And so for 100 years, or we should say 99 years, their calendar was functioning properly. There was nothing wrong. It wasn't until that 100th year where it's like, wait a minute, this day is not where it's supposed to be in relation to, whatever they were looking at. But since the Europeans, they were not using astronomical phenomenon, they probably didn't notice it in 100 years, maybe not even in 200 or 300 years, until the error accumulated and they started to notice, wait a minute, there's 7 days, there's a whole week of error in our calendar. What's going on? And then they had to go and fix it, and then of course convert Julian to the Gregorian. So again, following the Rafael Tena is like following the Julian calendar of the European timekeeping practices. And so it's more accurate than Caso, but it does not adjust for this error. And so that's the critical fault of the Tena, that every calendar you have to do the leap year, but you also have to have a secondary adjustment every 100 years. You have to account for this 1 extra day. If you don't, it's going to trail off, and that's exactly what has happened to Tena's calendar. And according to the one I showed you from Arqueología Mexicana, it's 7 days of error. So let's go ahead and plug in. We're in 2023, and we're going to subtract. We'll do 1521 because that was the last year in which the Azteca Mexica Tonalpoali, or calendar, was accurate. We know it was accurate in 1521 because the Tonalpoque we're still adjusting it in Mexico Tenochtitlan. And so this turns out to be 502 years. Okay. So remember I said it takes every 100 years for the error to accumulate. So we need to divide this number by 100 years to see how many days have accumulated since that year. And so it's exactly 5 days, which is not the same amount of error as I showed you here. So you remember, as I showed you, it was actually it was 7 days of error, right? And so this is 5 days of error. And so again, it's a question of what's going on. It's the same thing that was happening with the azteccalendar.com with Caso. Whoever is doing the Arqueología Mexicana, they're making some kind of extra error, so there's error again on top of the error, because if you're following the Tena correlation using just the simple math that we did, we'll see where it's supposed to be. So again, we're one tekpat today. So there's 5 days of error according to our math. So it's 1, 2, 3, 4, 5. So if they were really following the Tena correlation accurately, they would have 9 akat. So maybe somewhere along the line, when they're doing their calendar, they forgot to do a leap year, or I don't know, something happened. And so their version of the Tena calendar is not even accurate to what Tena himself says. And so, a lot of people who don't follow Caso, they'll say, oh, use the Tena. And, a lot of people I notice don't really understand why they're suggesting to use it. They just say, oh, a lot of people in Mexico use it. They seem like smart people. They're professors and archaeologists. So, follow it. But, the reason should be, well, he incorporates a leap year, but he does not account for that secondary correction. And so if we want an exact calendar, right, that's not going to be it. We're not going to use that. It's not going to be useful. And the only calendar that's going to be 100% accurate is going to be the Ruben Ochoa correlation. And the reason for that is he incorporates the leap year. He also has a secondary correction, which, again, if you're following the equinox, right, like you don't like, there was a linguist, Magnus Farrow Hansen, he said, well, you don't even have to worry about the corrections, because it's not like the Europeans where it's just based on January 1st, which is an arbitrary day that's not related to anything astronomically. Our calendar starts an astronomical phenomenon, a day after the spring equinox. Therefore, if you're doing that every year, okay, it's the day after the observable spring equinox, it's synced every single year. So you never have to worry about it trailing off. And so, he argues, well, you don't have to even have a conversation about the leap year or the secondary correction, which is, a pretty strong point. Let me go back to Tena, because, again, these researchers, they're not dumb. Like, they know what they're talking about. And so he says that, it's February 26th is the first day. So he says it right here. The fixed beginning of the Mexica year on February 26th. And so Arqueología Mexicana got that right, because they're starting that on their Instagram account. At least they're starting it on that day, which is what Tena says, right? Now, he says something so interesting right here. He says, however, since all the arguments that can be adduced to prove the existence of periodic adjustment among the indigenous people are based on data from colonial sources, some authors conclude that we are facing a typical case of cultural contamination, since when ultimately it was intended to assimilate the pre-Hispanic calendar to the European calendar. So the fascinating problem posed to us by the history of science remains open for discussion, like many other problems relating to calendars. So Tena himself is acknowledging, like, it's just like Caso, here's my research, do whatever you want with it. Well, what do people do with it? They make a calendar out of it. Same thing with Tena. Here's my research. Okay, everybody went and they made a calendar from it. And he's saying, well, I'm basing everything I'm saying off of colonial sources. And by starting the day on February 26th, he's doing the same thing that the Europeans did, starting on an arbitrary day, January 1st. And this is a critical fault of most of the correlations that, of course, claim to be the same as the calendar in the Mexico Tenochtitlan, but they're not, because as he's saying, you're tying the pre-Hispanic calendar to the European calendar. And so you're saying February 26th is the beginning of the day, but you're utilizing a European Gregorian date so it's complete 100% colonized view, right? Why would the Mexica begin their year on February 26th? The Mexica didn't know what the hell February 26th was. It's a Gregorian date. They did not know what that was. February 26th does not correlate to any observable phenomenon. Our ancestors were astronomers, they were scientists, they were measuring the movement of the sun against their Teocalli. So if you don't have a date that is tied to an astronomical event, well, you know that you're just basing it off of tying something to the European calendar, which our ancestors would not have had. And so we know there's no way that they would have started their year on February 26th. It's not even possible. And so it's really cool that he acknowledged that limitation here. Obviously a lot of the followers are not going to acknowledge it, especially if they have, some, they have some cultural importance to this particular calendar. But he's exactly right. You can start the year at any time you want. You can say, oh, okay, I'm going to start on one Kali. Okay, I'm going to start on this. You can start it whenever. And there's evidence that, differing indigenous groups started their calendar in different points of the year. So you don't have to start it at the same as the Mexica Azteca. The thing is, we're talking about the Mexica calendar, and therefore we have to utilize their start date, which we know is the day after the spring equinox. Okay. And so it's a different thing because I'm not saying any Gregorian date, any European date. I'm telling you it's the day after the observable equinox in Mexico. So you see the difference? I'm using a solar phenomenon rather than a Christianized date, which is what a lot of people don't understand when it comes to the errors of the calendar. And so I'll leave it at that. This one will be kind of short just because it's building off of the Alfonso Caso count. Now people ask me, well, does it have any value? We know there's an error. Well, does it have value? I don't know. Maybe somebody can go to the Arqueología Mexicana Instagram and use it in some way, just remembering those 7 days of error. Like, I don't know. But of course, the easiest thing to do is use the tonal quali that is 100% accurate. This one has all of the corrections built into it, and so we know there's no error accumulated. And so it's exactly the same as the calendar in Mexico Tenochtitlan at the time of the conquest. And so that is the Rafael Tena correlation. I hope you enjoyed this video, and I hope it was valuable for you. Thank you, everybody, and I'll see you next time.